Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at tree diagrams. So whereas Venn diagrams and two-way tables are used in probability when you have two or more sets, tree diagrams are used in probability when you have two or more stages to the events. What we do with tree diagrams, we use them to list all the possible outcomes. So in this video, we're going to look at tree diagrams where the experiment's done with replacement, which basically means the probabilities don't change at each stage. So these things probably don't make a lot of sense, but hopefully they will after we do an example. So let's look at this example. I toss a coin 3 times. Calculate the probability that I toss either all heads or all tails. So this is not an easy question to do off the top of your head. We're going to use a tree diagram. Now we know to use a tree diagram because this is something that occurs in stages. If you're tossing a coin 3 times, you're doing 3 things. So what we do with the tree diagram, we list the outcomes at each stage. So we're going to have a column here where we toss the first coin, then we're going to toss the second coin and the third coin. Remember, the point here, the point of making the tree diagram is to list all possible outcomes. So at the first stage, if you toss a coin, you can either get heads or tails. I know, really complicated. Similarly, when you toss a coin second time, you can get heads or tails. So what we need to do is draw some branches here, because if you got a head the first time, you can get heads or tails the second time. If you got tails on the first toss, you can still get heads or tails on the second toss. So these branches here, these are called branches. That's why we call it a tree diagram. And similarly, for the third toss, we can get heads or tails. Regardless of what we got before, we can get heads or tails. All we're doing here is listing all the possible outcomes. So when we have done all the branches, let's list all the possible outcomes. We do this by following branches. So the first outcome is head, head, heads. If you toss a coin 3 times, you can get heads all 3 goes. The next outcome is head, head, tails. Again, just follow the branches. Head, head, tails. Next one is head, tails, head, and so on. You'll see that there are 8 outcomes in total. So the reason there are 8 outcomes, there are 2 outcomes at each stage. So the total number of outcomes is 2 times 2 times 2, which gives us 8. Now, each of these 8 outcomes is equally likely. The probability of getting all 3 heads is 1/8. The probability of getting head, head, tails is 1/8, and so on. Each of these has 1/8 probability. We have successfully listed all of the possible outcomes when you toss a coin 3 times. That's what a tree diagram is for. So calculate the probability that I toss either all heads or all tails. All we have to do is go through these outcomes and circle which of them satisfy this, which of them include either all heads or all tails. Well, we're definitely going to include this top one here because that's all heads. This outcome here, head, head, tails, it's not all heads, it's not all tails, we don't include it. And we keep going down the list. Head, tails, head, tails. Well, that doesn't work because it's not all heads, it's not all tails. But if we go to the last one, we see that that's included because it's all tails. So we've been able to make this much easier. We see there are 8 equally likely outcomes. 2 of them are all heads or all tails. So the probability I toss all heads or all tails is 2/8. And remember, if you're giving a fraction, make sure it's simplified. All right, let's now look a bit more at what we meant by with replacement. So that first example was all well and good because each of the outcomes was equally likely. But let's look at an example where they're not equally likely. When that happens, you need to write probability on branches and then multiply them. So here we have bag of lollipops containing 7 cola, 5 watermelon lollipops. We're going to pick 2 lollipops, one after the other with replacement, and calculate the probability that we pick one of each kind of lollipop. So this is a multi-stage event because we're picking 2 lollipops. We're picking a first and then a second. So let's list all of the possible outcomes. So on the first go, I can either get cola or watermelon. Then on the second pick of lollipop, I can either get cola or watermelon. So here we have 4 possible outcomes. We can get cola, then watermelon, and so on. The thing here is, though, what makes this question a bit harder than the previous, each of these 4 outcomes is not equally likely. On each go, you're more likely to get a cola. So what we need to do is we need to write the probabilities on the branches. So for the first go, your probability of picking cola is 7 out of 12. There were 12 lollipops in total, 7 cola, and 5 out of the 12 lollipops were watermelon. So at each stage, the probabilities should add to 1. Now here's the part about with replacement. In order to calculate probabilities, we need to know whether the lollipops were picked with or without replacement. We need to know after you pick the first lollipop, do you replace it with an identical one or not? So in this question, we're told it was with replacement. That means if you picked a cola the first go, it's replaced with another cola. The case where they're picked without replacement will be explored in a different video. But because they're picked without replacement, if I pick a cola, if you pick a cola the first go, then I replace it with another cola, it means that the probabilities don't change. So it means on the second go, you'll still have 7 over 12 probability of cola, 5 over 12 of watermelon. You'll still have 7 out of 12 probability of a cola and 5 over 12 of watermelon. So this is what I meant on the first slide, where I mentioned that with replacement means the probabilities don't change at each stage. You'll see in the later video, if this was done without replacement, the probabilities on the second go would change. Okay, so we've still got our 4 outcomes. How do we find their probabilities? Well, what's the probability of 2 colas? Well, it's not 1 over 4 because, again, these are not equally likely. How I find the probability of each outcome is multiplying the probabilities on the branches. So the probability of getting 2 colas is 7 over 12 times 7 over 12. Or 49 over 144. Probability of getting a cola then a watermelon is 7 over 12 times 5 over 12. We always multiply the branches here in tree diagrams. So similarly, the probability of watermelon then cola, 5 over 12 times 7 over 12. And the probability of 2 watermelons is 5 over 12 times 5 over 12. So these probabilities, once again, they add to 1 because probabilities have to add to 1, just like percentages add to 100%. So how do I answer the question? I found the probability of each of these individually, but how do I find the probability that I pick one of each kind of lollipop? Well, just like we did in the previous question, we're going to go through and circle the outcomes of interest. These are the 2 ways that you can get 1 cola and 1 watermelon lollipop. So what do I do with these probabilities? I actually add them up. So this causes people a lot of confusion. You need to multiply along the branches, but you need to add when you have the probabilities of each outcome. The probability that either this or this happens is just the sum of their probabilities. So 35 over 144 plus 35 over 144 is 35 over 72. Once again, I added up these probabilities. That gives me the probability that either happens. So the probability that you pick one of each kind of lollipop is 35 over 72. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.